Kia ora Year 12 and 13 and anyone else watching who's been coming to the Saturday calculus sessions. In this video I'm going to do two of the ones I went through yesterday, but I'm going to go pretty slowly. I suggest that you watch video 1 first unless you're already quite confident with combination proofs. So just thinking about what is a combination, well, when we write n choose k, that means choosing k objects out of n objects, and we don't care about the order that we put those objects in. And that's defined as n factorial over k factorial times n minus k factorial. We can also write that as n choose k. And in this question, we've got k and n are both positive integers, and k is smaller than n, and we have to prove this property here. So to start with, what I'm going to do is just explore what this factorial on the left-hand side, on the right-hand side is like, and then I'm going to go from right back to left. I think that's slightly easier. I did it the other way around on Thursday and got told that I had done it the bad way. But that's all right. So n minus 1 choose k minus 1 is equal to n minus 1 factorial over k minus 1 factorial times n minus 1 minus k minus 1 factorial. And we can clean up this. Ending up with n take away 1 plus 1 minus k. So that simplifies quite nicely down to this. And you should be starting to see where we're going to go in the second part of this question. So we've started by just looking at that. Now we're going to sort of formally move into what we're doing. So on the right-hand side, we've got n times this combination, which is n times n minus 1 factorial over k minus 1 factorial times n minus k factorial. And as we often have in combinations proofs, we can use the properties of factorials to simplify the numerator. So n times n minus 1 factorial is just n factorial divided by all of that. Now go back to where we're trying to get to. We want to end up with k times n choose k. And you can see that we're just about there now, right? The only thing that's wrong is, I'll just change the colour of the pen, that this needs to say k instead of k take away 1. So to have k factorial instead of k minus 1 factorial, we can times the top and bottom by k, which leaves me with k times n factorial over k factorial, oops, lost a factorial sign, times all of that. And then all of this is equal to k times n choose k, which is equal to the left-hand side as required. Okay, so I've just chopped the video off because I'm going to redo part D. I think it is going to fit into this video. But I just want to make sure that I'm explaining it really, really slowly. So for some of you watching who got nearly there on this yesterday or on Thursday, you're going to find the second half of the video too slow for you. Just put on double speed or skip through it. Just make sure that you can follow all of it. So in part D, we've got what is obviously a more complicated proof. But there are two things that we can use in here, and one of them is from yesterday's video. So in yesterday's video, we learned that if we take the nth row of Pascal's triangle and we add up all the entries, we get 2 to the power of n, which was pretty cool. So we can say this, and that means that when I'm looking at that 2 to the n plus 1, the very first thing that I see when I see this question is I see that, and I think, okay, I'm going to start by using that. So 2 to the n plus 1 is the n plus 1th row. Hang on, what am I doing? I don't know where an n plus 2 came from. Right, n plus 1 choose 2 plus ... plus n plus 1 choose n plus n plus 1 choose n plus 1. Now, you'll see that in the numerator here, I need to subtract 1. I've got a couple of choices about how to do that. This is equal to 1, right? And this is equal to 1. I'm going to get rid of this one here, because I can see where this proof is going. I think that you might not see that the first time you do this question, but you'll see why in a minute. So what I'm going to write down now is 2 to the n plus 1 take away 1, and I'm going to start with this term here. Right? So I'm just going to take off the 1 by taking off the first term in that in that sum. And we go all the way out to the end of that row, and that's what we've got. Now, there are several ways to go from here, but if you've thought about the structure of these 4 questions, and you might have listened to the hint that I gave you if you were in class, they're really sequential, and we can use this result here to help me in here. You'll notice that on the left-hand side, I've got stuff out of row n of Pascal's triangle, and over here, I've got stuff out of row n plus 1. But up here, I've got the link between the 2 rows of Pascal's triangle. And I'm going to use that now. So I'm just going to draw a little bit of Pascal's triangle out to give you a feel for what this result says with some easy numbers. So if we hop over here and just write out the first few rows, I'm just going to go down to row 5. What my result above is saying is it's this thing that says k times n choose k is equal to n times n minus 1 k minus 1. So let's circle up a number in here. So 10 is equal to 5 choose 2. So n is 5, k is 2. N minus 1 would be 4 choose 1. So it's saying that there's a link between these 2 things, that I can hop back from the 10 up to the 4 with a couple of multiplications. So it's saying if I take, let's see, 2 times 5 choose 2 will give me 2 times 10, which is 20. And by the result that we showed above, that's going to equal 5 times 4 choose 1. And it does, right? So it works, right? Of course it works. We just... Okay. We're going to use this result now. What I'm going to do is I'm going to take all of those n plus 1 terms and I'm going to move them back into row n terms. So 2 to the n plus 1 take away 1 is equal to what? Well, we need to adjust this. So the result that we're using is worth writing out at the side before we dive in and we screw it up. So over here, we had this result here like this. That means that I can write something from the nth row like this. Now guys, this is the bit where I said I was going to go really slowly. Okay, so if you're finding this very easy, just skip ahead. What I'm doing now is I've said this result links row n and n minus 1, but we want to have it linking row n plus 1 and row n. That means that where I see n, I'm going to change it to n plus 1. Like this. And where I had n minus 1, now I'm going to have n. And that gives me the way to switch out all of my terms. Okay, so instead of n plus 1 over 1, that's going to come out as a fraction. And now I'm going to drop my n, and it will just be n choose k. But it won't be k. Hold on. This is why you should not make YouTube videos in the evenings. Right, okay, n, and that will still be 2. No, it won't. It'll be k minus 1. Oh, why is my brain so bad tonight? Okay, that's k minus 1 in there. And that's 0, and that's 1. That's better. Okay, and the next one will be n plus 1 over 3 times n choose 2. Right, going over that one more time because I've mucked it up so badly. You can see that here I've got k, and here I've dropped it by 1. Okay, k, and I've dropped it by 1. So here I've got 1, and I've dropped it down by 1. And I keep on going, and I get n plus 1 over n. That should have a plus 1, n plus 1 over n plus 1, and then I'll have n here, and I'll have n here. Right, let's clean some of this up. Well, I'm going to look back at where I'm trying to go with the proof, because so far I've worked with 2 to the n plus 1 take away 1. But that's not what I was being asked to do. I was being asked to divide all of that by n plus 1. So finally now, I'm going to do right-hand side 2 to the n plus 1 minus 1 over n plus 1. And you can see that you've got this constant in all of them, the n plus 1 here. So you've got 1 over 1 times n choose 0 plus 1/2 n choose 1 plus 1/3 n choose 2 plus 1 over n plus 1 times n choose n. And that is exactly what we were asked to prove to start with. Okay, so that equals the left-hand side as required. All right, thanks for watching. I've got one of the proofs from the weekend left to do, which is the hard one in question 2, and I will try and get to that tomorrow or the next day. So let me know in a comment or by email if you've got any questions on this one. There is another way that you can do this. You don't have to use that result. You can do it manually with manipulating the each term. You can also do it more elegantly using sigma notation, but I prefer to do it where I write out a whole bunch of the terms so that you see the patterns and you see what's going on.